Okay, so we continue with lectures, and this is on data types, right? Now, remember that we said that in now we have data structures, right? Now, we've looked at vectors, we've looked at matrices, data frames. So the vectors are one-dimensional array, data frame and matrices are two-dimensional. You can have array which can be several dimensions. Okay, so we can stack like data frames together to form like a block under arrays. Okay, so you can read about that as well. Okay, and then we talked about list, which is the most complex data set in our data structure in our. Then, at the beginning when we talk about vectors, I talked about data types. So we've seen some before, like age. Okay, so age, weight, those are all numeric, right? And then we saw also character. Okay, so first of all, the data types. One we've seen numeric. So numeric. Okay. Now, so for numeric, you are looking at numbers, right? It could either be or integer or double, okay, in R, and then also so we either sometimes it may be named as or num, which is numeric, okay, or it may be done as integer. Usually, when you um, let R use, let's say, the colon, okay, to get you a sequence, I would usually will store it as what? As an integer. Okay. Whereas if we generate things, generate observations from a distribution or we randomly sample, sometimes you will see that as integer. There's not much difference between this, except when you have to do programming where you are checking data types and so for that. Other than that, its usage is basically the same. So usually I will either store numeric data in the form of a double or integer. But in practice, you say that numeric is almost always a double um, 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 data. The double means it's like real numbers, right? That's what we see. So if you want to look at it, um, you can do question mark double, okay, and double precision vectors, so create coerce or test for double precision vector. So double is mainly like a real number, and we can also have an integer, okay, which is what you will see as int, int, and so forth, okay. So integer vector, okay. So create or coerce, we can check if as then we want to convert it to integer, if we want to check whether it is integer, and so forth. Okay. So we've seen this in the form of age, right? So age, remember we've already defined age, so I'm not going to go back again. Age, okay, so I think we age, yeah, so it's numeric, right? But in this is integer because remember we use a colon sign to um, declare them IND and like IND1, IND2. We use that to do it. Okay, so that's it about um, numeric. Then we also saw character. Okay, character. character data. So what do we mean by characters? Okay, when we um, so characters are just like strings, okay? So it can be letters, or either one letter or two or more, which is that strings put together. Now, so we do this in R by what? Using the quotation marks, either the single one or the two double quotation marks, right? To signify a character. Okay. Now, if we have a character, um, like religion, we've seen religion, right, which is character and so forth. So we can call religion like this. If we display it, you see everything is in quotation marks over there. Okay. Now, there are certain things that functions, useful functions for characters, like a cat. Okay, so cat, I can write a sentence and use cat to display it on the screen. This is my first sentence, something like this. Okay, so usually when you are doing programming, you want to, so you see it has displayed on the, so it's used to print on the screen. We can also use print, okay. Usually when you are doing programming, let's say a simulation, and you want to check whether your simulation has run and so forth, we can actually use cat to show that if it is iterating. So if it gets to iteration one, you write iteration one completed, iteration two completed, and so forth. Another function for the tracing characters is paste, right? Paste. Okay, so that helps us to even add more things to what print and cut can do. So, for example, I may add another thing like, let's say, I can say that the sum of, okay, then um, I can bring 10, right? And and uh, and 20. Okay, is, so I can write this sentence is equal to 10 plus 20. So I can do this, and you see it's written it on the screen that the sum of, okay, 10 and 20 is what, 30, and so forth. So paste allows us to add so many things, and when we get to plot and so forth, we can use paste to, let's say, write a formula and other things, paste with expressions and so forth. So we'll come back to that as well. Then another one is ncar. Ncar. So ncar of let's say religion, okay, will give me the number of characters in each religion. So you see the first one is Christian. Christian is made up of those ones, right? Christian is made up of 9 characters. This one is all 6, and so forth. Then tradition and so forth. So there are so many of this, and you can check them at this session. Okay, so each of them, it will give you some brief description of how this can be used. Okay, and basically letters as well. The letters of the alphabet are stored in R. So if I if I call letters, the big ones, I'll get all the letters for what? For capital letters. Okay, and then if the small letters are also stored in R as well. So these are all characters and some of the functions you can use on character vectors. Okay, the next one I talk about is logicals. We've seen logicals earlier. These are the true or false. Like will vote. Okay, will vote. Will vote is will, will vote is logical. So I display it like this. Okay, and you can display that as that. Okay. Now, so for logicals, you there are so many um will vote. Okay, I can also age, right? We can check which age is greater than something, greater than let's say 20. We get logicals at the end of the day. When we have I can also negate, right? Okay, so I will vote if I negate this, right? Using the exclamation sign, okay, I'm going to, you see the true becomes false and then false becomes true. That's negation, right? I can check if X and Y, so let me show you that table as well. So the table for logicals. Okay, so here X and Y element wise, it will compare them, and then if it's true and true, then true will show up. Other than that, it will be odd, false. Then X and Y, this one double end will return a single value. If everything is satisfied, it will be odd. True. If not, then this is all. This should be only one and then the other one. So I correct this in the test. It's already been corrected. Let's see. Okay, so let's see. Uh, we compile. So I'll compile that. It's already been done. So and then we can have x greater than all those relational operators. We can do it. So equality is double equal to. That's why I say I don't want you to be using X or to be doing assignment statement with equal to. Okay, because equal is also a relational operation. If I say X equal to Y, equal to Y, then I'm checking whether they are equal, and then not equal to is also with the exclamation sign as has been done. Okay. Um, these are some of the things, okay, that we can check if X is the true, true if X is true, otherwise it is false. Or, I can check a condition if all of them. So, for example, I have age, right? And all, I can say all age greater than 25. This will check whether all of them is greater than 25. It is not, so you get false, right? Because some of the values are less than 25. Okay, but if I put, let's say, 15, okay, or this will be true because every age over there is greater than 15 and so forth. So that's some of the things you can then identical. It's, if X and Y are identical, okay, and then all dot equal to, check if they are all equal to. So there are some examples in here. Okay, so this is modulo, okay, operations. So x divided by 2, okay, and then the remainder, if the is modulo mass, so if the remainder is 0, then this is equal, and then if x is greater than, so you must get the 2, other than that you get false, right? And so forth. So you can go through it and uh, go through and display them and also assess assess them to be able to understand it well. Okay. All right. So let's move on to that will be it for logicals. Okay. Um, then now talk about I've talked about characters. Um, then factor number 3 or 4. Factors. So I said earlier that in some books, factors are maybe considered as a data structure, right? But here we consider it as a data type. Okay. So basically, factors helps us to create a data that can be or that can have a level of measurement either nominal or ordinal. Remember from basic statistics, a nominal level of measurement means you group, right? You just group them, right? According to uh, you group them according to just groups. There's nothing attached to them, right? Or there's no order attached to them. That's what I want to say. So, for example, we can group ourselves according to the shirts, the color of shirts we are wearing. We can group ourselves according to gender, male or female. We can group ourselves according to the region we come from or the town you come from, and so forth. All right. So there's no order attached to this. However, in some situations, for example, the grades that you get in an exam, A will be better than B and so forth. You are let's say if somebody has, let's say, kidney problem, they have stages of it. So there's some stage that the doctor will say, you can't survive this. Okay, so that has reached a stage where you've got to a point of no return. So when it starts where you can use dialysis or even with just some common drug to be able to sustain you, that is not severe enough. So in some cases, you have what they can be grouped according to, or maybe you go to a hospital, you go to their trials or so, you see that they will color. If temperature is greater than maybe 40, then the person is in danger. So you must act quickly and so forth. So that's how you have color to do it to show severity of such temperature. So that's under the word the ordinal scale of measurement. So that's what factors gives us. Okay. So um, what do I do? We can get an example, but first of all, look at factor. Health files for factor. So if you look at it, it says what? It's a factor. Usually you need characters, right? Then the levels and then the labels. Okay. Labels are usually assigned the levels, right? And then the keyword ordered is not ordered is true. If ordered is true, it means we are under the uh, ordinal scale. If it is false, then we are under the nominal scale of measurement. So let's look at uh, some of the data sets that we looked at earlier. So, for example, the anorexia data. Okay, uh, it means we have mass. Okay, so if you look at this, it's in mass. Okay, now what I want to do is that I want to look at the structure of usually our in data frames. That's why we consider it as a type. So if you look at the data frame, look at this one. It treats it as a factor. So you see that a factor can be considered as a data type because it's in within the structure data frame. So you look at factor. This is a factor of what? 3 levels. But here we have not assigned any order to it. So this is under what do we call it? Under um, the nominal scale of measurements, right? So that's what I mean by this. But we can also create a factor. If we want to create a factor, we say factor. Okay. So for example, I let me say the anorexia data. It's already a factor, but we are saying that if we are creating a factor, this is what we do. Okay. So factor. So this one, there's no order attached to it. So it starts from continue like this. Okay. And then the levels are just three. Okay. Three of them. Now, if I want to order, then I can do so. If I want to change it to this one, I can say levels. Um, okay, the levels. Then I put this into quotation marks. Then I bring my this thing. Okay. Now, if I want it to be then ordered, I'll say true. Okay, if I say ordered is true, then what is going to happen is that you see that there's order, right? And this order is according to the way I have arranged them. So CBT is less than what? The control, which is less than that one. If I want it in the other way around, that the family treatment is better than this one and the other one is better than that, then I need to do it this way, right? I need to do it this way. um sorry, I'll need to do it in such a way that this will be like this. Okay, so if I do it again, you realize that this one, you see, now it has changed. So the first one will be considered as the smallest unit, and then it moves to the next one, and then the last one, and so forth. So that's how you create a factor. Okay, it is important that some when we read a data set and it's a matrix and you want to convert it into a data frame, then you need to put some of this. So very soon in the next video that we'll watch, we will be reading data from some sources. When we read, we can factor it into like an ordinal level, like what I have done now. Okay, so that's it about factor. Okay, and so forth. So the next thing, we take a look at dates. Okay, yeah, so let me go here and then you look at dates. Okay, so dates and time. Okay, now so an R object, dates. You can have some that are dates and also dates and time. Okay, so we can look at the question mark for date, that help for daytime classes. Okay, if we go here, it's an inbuilt so V is an inbuilt dates and time. Okay, so you dates. If I start typing dates time classes, okay, it will tell you daytime classes. Okay, so proceed how to print um, summary of that and so forth. Okay, so here that's what seconds is from 0 to 61. Okay, second minute is 0 to 59, and then hours you up to 23, and then day will start from 1 because 24 is 1 day, and so forth up to year. Okay, and then weekday, and then year in year day, right, and so forth. Okay, so zone, game time on, and so forth. So we can use this. We can also look at dates. Okay, dates. Okay, so dates yeah, is an object. Okay, so we can get system.date or sys.time and so forth. So sys.date, if I want date like this. and then I run it. I'm going to get a date, okay? I can also get sys.time, sys.time, okay, like this. Okay, so it gives the date and then the time that you are doing this. Okay, now um, then there are some functions for dates, okay, or for constructing dates, okay, and even sequencing dates that will help us to do time series. So time series data, right? And so forth. So if you want dates, um, you you can use as.date or just you, you coerce it to become a date, right? And we can sequence from it. So just an example of of dates. Okay, so I can say date um so DAT one. Okay, let's say I have this like um like 6 March 2011, and then the next one I have, let's say, so these are characters, right? In this one, but I can convert it to date, right? This is June 2012, and then let's say 21st May 2013. So let's assume I have these three things. Okay. Now, um, I can convert it to date as the date as the date, right? Then I call this, okay, we can, okay, so let me see. Um, that if we can get the as.date, so you can look at this help files, the help files for as.date to know what we are talking about now. Yeah, so just question mark as.date, okay. So date one, okay. Then I can format it. So the format of this date, okay, is equal to then you have the percent. Remember we have day and then what? And then B for the month, okay, and then year, okay. But I must put all this into quotation marks, okay, like this. So the day, the month, the year, and so forth. So if I do this, you see it has now written this in terms of what? 2011 03 and then 06. Okay, 6 March 20, then 2012 and so forth. So I have my date string now and so forth. So that's how we can do it in another format if we wanted to change to another format, we can do it and so forth. So basically we have dates as in um, date, and then we can sequence. The way we did sequence, we can also do sequence of date from to and by or length out, just like we did previously. So, but now you have to put in your date, not values. Okay, so that's it about dates as a data type. Okay, next we will come to this dates and so forth when we talk about time series data. So when we start reading data set and we get something in time series, you will see that date will be important in there. So V, we also have a missing data. This is very important in missing data. Now, in statistics, usually you collect data. There's a tendency that, you know, people will not answer questionnaires. Okay. So, for example, if you send questionnaire to someone and you are asking of the salary of the person, it's a bit sensitive, right? So sometimes they will just leave it out because the person doesn't want you to know the exact salary the person is doing. Or you are asking questions, personal questions, whether the person, you know, um, let's say smoke, okay, or the person has contracted some particular disease and so forth. In such cases, you may not get responses, okay? So, and remember that our data set usually is in what? A data frame. The data frame must maintain its rectangular nature. Okay, so if somebody does not provide the age, okay, or the salary that the person is receiving, it means you have a missing value. So what do? You can't, if you leave it blank, it will distort the nature or the structure of the data, and then you can't even you store it in R. Okay, so missing data is quite important. How to treat them? So in R, we treat a missing data with the name NA. So when there's NA anywhere, we say it is what? A missing data. So let's say if I ask um, 5 people to give, uh, let's say we had age 2, right? I asked people to give us their ages, and then the first person gave his age. The next person, maybe when we collected the questionnaire, there was no age. So we put NA there. The next person answered. The next person also answered. The next person also answered. So we have this. Okay. So if I run this, I have this one. Now, this will help us, okay, to construct a 6 by was our distance 6. Let me see. I think it was 5. Height is it was 5, right? Okay, so let me take one out and then so I can add it to you. Okay. So now I can combine this with what our previous matrix, which is math 3 and what A2. A2, right? So I do this. You see, NA is here. If we did not have the NA, it would have distorted the structure of this data, and that will not, will give us either a warning or will not do it at all and give it an error. Okay. Now the question is, when we want to proceed to do any computation, for example, we want to find the average age of the people in A2, then you realize that we'll get what? NA. All right. But R makes it easy for us to do this without necessarily um, um, including the NA. So what we will use, the argument you use is NA.RM. Okay, so it's a NA.remove. If we say true, it means remove it before you find the average. Okay, and we get the average. Okay, so and in some cases you can use NA.exclude. That also works. It can also exclude NA from from it. So I can say NA.exclude. Okay, so if I say NA.exclude age 2, it will exclude that NA, and then I can put any, you see, it will tell us that NA action 3 was removed, and we are left with 4. So that way you can compute the mean or any other thing you want to do with it. So that's it about missing values, and that's also important in um, in R. Okay. Now, also, there are others. For example, if we divide 0 by 0, we 0 divided by 0, you realize that we'll get none. Okay, this one is not a number. Okay. In some cases too, there will be nothing in there. All right. Okay. So if there's nothing, we say now. Okay. Null object means nothing satisfies it. Okay. Um. Yeah. So, and then also, if we can also check coerce or check whether, let's say, a vector has some NA component, right? Is dot NA, like let's say A2, this one will get what? False, 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 false. So where the NA is what you get it. So we can use this to, select NA from a value. So A2, if I take A2 and I do this, okay, it will select the value NA for me. And then for if it is a none, we check is dot none. If it is null, is dot null. And then we get it. Okay. Now, so we've seen that we can convert, okay, every we can check and also coerce. Okay, so the first we want to check whether a data set has any, we say is dot this. If it is um, a vector, we say is dot vector. So we have a table like this, okay, then the type and then the array. So array is dot array, then we check. If we want to coerce, we do it like that. Is dot character. If there's a character in there, we get true. And then as the character means you are converting it into what? A character. Okay, data frame is dot data dot frame as dot data dot frame. Factor, list, logical, matrix, numeric, and then vector. All of them we can so play around with it using question mark of it, and then we'll continue the next time.